I'm
81 people and 13 time zones.
okay. I'm
I
used
love it.
I'm used to doing talks where no one listens to me. I teach,
Okay.
right?
Oh, okay.
And nowadays, when you're teaching over Zoom, what you find out is
Yeah.
that nobody, everybody's eating and checking their email and stuff like that. Uh, so I'll go
They were
ahead.
doing that in class anyway. You
Yeah,
just
yeah. I'll go ahead and start in on the presentation, and anyone who wants
um
can.
if you're not in a rush, we could give a couple minutes
Okay,
just in case because I just did in that channel. I just did the most invasive
okay,
blast that Slack lets me do.
okay.
Um
All right, we'll give them 2 minutes, and
sounds good.
then I will I will kick off. I can always edit this down. I'll edit it down to just be
Yeah.
the
Yeah.
presentation
We can
before
do.
I post it. Is there a place where when we're done we can post?
Um, yeah, I was actually just thinking about that because we've had a few. We're we're kind of adding some more. We want to. Well, I think we want to add some more community resources and different things like this.
Okay,
Um,
all right.
so I think Carl's has a few that he's posted on the website.
Okay,
Um, and if we post there, we can share it in Slack. The Slack we don't pay for, and it's very an ephemeral thing,
yeah,
which I'm like, I think this kind of communication, I'm actually kind of like it being somewhat ephemeral.
yeah, yes,
That's just my personal thing. I know a lot of people
yeah,
want like the recorded history forever, but I'm like, no, just let it be ephemeral and you need to document stuff.
yeah, yeah.
So,
Yeah, you can put this on the website if you want to. It'll end up being about
yeah,
50 meg of an MP4 file.
yeah, that should be
Okay.
fine. And you're welcome. Obviously, this is your content, so you're welcome to share or do stuff
Yeah,
with whatever. But if you're willing to let us
sure.
kind of keep it and share it.
Yeah. All right.
Um,
I will need to get started because I'm
okay,
at, at
that's fine.
one Eastern. I'm going to need to drop off. Okay.
Okay,
So my name's Van Simmons, and I've run a project that has like one or two other contributors called the Swift Cross Compilers Project. And I'm going to be talking about that today. So for my main, my day job, I write apps for the iOS platform in the Swift language, and I also teach that I teach iOS development. In the past, I've taught at Harvard. I won't be doing that this year, but I teach at Tufts. Currently teaching a software engineering class there. In the fall, I'll be teaching my normal Swift and iOS class to Tufts CS undergrads and graduate students. Additionally, I've started up with a partner. I've started a startup that is targeted at this kind of interesting thing that we're doing playgrounds. And what I mean by that are the actual playgrounds with monkey bars and slides and things that kids play on. So I'm going to give you some of the motivation behind why I'm into doing cross compilers for Swift and why I'm interested in hearing from the Arduino community on that. So our project is called PlaySpots. And my partner formerly was the CEO of a nonprofit that builds playgrounds for underserved communities. And his concern has been kids don't play enough. And what he wants to do is to make playgrounds more interesting. And by interesting, it needs to be interactive. It needs to do something different every time a kid comes, and it needs to have sound and music. It needs to have light, it needs to have motion detection to know that kids are there. It needs to have touch sensors. And most incredibly, he wants this to be programmable by kids. And so we're going to talk about sort of how that happens. So we've actually gone, and over the course of the past 4 years, we've built this thing. This is a schematic of a typical playground with one of the PlaySpots installations involved. that the interesting things for this community are, you see these little things that look like green eyeballs that are scattered around the playground. Those are our satellites. Inside each one of those is something that kind of corresponds to a 16 light NeoPixel. There's high definition sound, there's a touch sensor, and there's a Doppler radar sensor. These are all on a Wi-Fi network that is controlled by a Raspberry Pi that lives in this totem over here. And there's an additional Raspberry Pi in that totem that also sits on the Wi-Fi network and drives a 64 by 32 LED matrix display. So the notion is we're going to build lots and lots of these. We've got 3 in the ground already. That the oldest one has been there now for going on 4 years. That we're, the issue is everything has to be outdoor proof for a Minnesota winter or a Phoenix summer or salt air like down around the Gulf Coast. So we're building that, and you can kind of see now why I'm active in the Raspberry Pi community. That our main device is Raspberry Pi 4. It's vending, it's a local Wi-Fi access point. It's got an MQTT server on it. And this is kind of the real trick, is that all of the satellites are getting on the Wi-Fi and talking to that MQTT server, and that's how they are controlled. We also have, interestingly, a power relay that's controlled on the GPIO pins sitting on that server. And that is a Swift NIO-based Docker container that also talks to the GPIO pins and can power cycle the entire playground whenever we need to do that. So all of the services that we run here are housed in Docker containers. And in fact, on this Raspberry Pi 4, we're running a Docker repository mirror. Our display server is also Swift, written in Swift. And it drives the LED matrix display. We're using an Adafruit bonnet to drive that over the GPIO pins. It also is MQTT controlled. It also sits on the Wi-Fi, and we can access the driver via HTTP because it's also running a Swift NIO-based server, and it will do OTA updates of the Docker containers over the Wi-Fi. And sort of this is where my desire to talk to this community comes in, that the satellites, and there are typically about 10 of them out on a playground, are ESP32 based. They also sit on the Wi-Fi that is vended via the Raspberry Pi 4. They also talk to MQTT, and that's how we control the things. We tell them to do things over MQTT. They have a 16-element LED ring. They also can be OTA updated from the Raspberry Pi 4. They have HD sound. They have radar motion detection and touch sensor. And I guess the thing that I've left out at this point is that the Raspberry Pi 4 is on the 4G network, and it actually is connected to a VPN that we run. So we can have a fleet of these things all over the place, and update the firmware for the ESP32, update the display driver for the Raspberry Pi 3 and the relay controller for the Pi 4 all over the air. All right. And we've got a new motivation now that I'm going to be doing. We've embedded all of this stuff in mobile enclosures that can come in off the playground. And we're running a Pi 400 to be the MQTT server, and we're embedding a lot of this connectivity into these big foam blocks that are made by a company called Imagination Playground. And I'll kind of show you that in just a little while. So the idea is to enable connectivity to these big foam blocks. All right, so you've seen that we've got some Swift running all over the place. Programming the Pis in this environment turned out not to be very fun. That, I started off doing everything in C and C++, that, I write Swift all day, every day. I know how to write Swift really well. I've been writing C since 1980, but I'm just not as good in C anymore as I used to be. So starting in about 2017, I needed a programming language that I was comfortable in order to write all of the software that we're assembling for this project that we're doing. My choices essentially were the C, C++, OBJ-C tool chains, or to do it in Swift. So I decided to do it in Swift. And what I found out, I needed a version of Swift that would run on Raspberry Pis. And what I found out was that there's a Slack group out there, and there's this repo called Build Swift on ARM, where people were actually building the Swift compiler for the Raspberry Pi. I thought, wow, okay, I can just write my software on a Raspberry Pi. The Raspberry Pi is really a pretty capable little computer. And so I started building everything in Swift on the Pi. Around 2019, I realized I was spending my whole life doing compiles, that the Pi is actually not that capable of a computer. And so I started looking around for cross compilers. And what I discovered was that Johannes Weiss of the Swift NIO team had actually already built a cross compiler for the x86 64 platform. That what he wanted to do was to cross compile. At that time, you could get the Swift compiler for Ubuntu and for CentOS, and I think one or two others, but mainly for Ubuntu. You could get the Swift compiler to run in Ubuntu, you could get the Swift compiler to run on the Mac, but there was no cross compiler. So Johannes Wendt went and did a cross compiler that would cross compile for x86. If you're running Swift on the x86 Mac OS platform, you could cross compile to an x86 64 Ubuntu platform, and then you could go and build your code to run in your Docker container, etc. And what I discovered was that subsequent to him doing that, Helge Hess in Germany had also taken his scripts for making that cross compiler for x86 64 and had made it run on ARMv7, so that there was actually a script you could run that would generate a cross compiler for Mac OS that would cross compile to the 32-bit platform for the Raspbian OS. And if you knew what you were doing and you held your mouth just right, and and the wind was blowing in the right direction, and you were really lucky, then you could get your Mac running on Intel hardware to generate a Swift program that you could then copy over and run on a Raspberry Pi. All right, this had some problems to it. And in 2019, I decided, I want to run a cross compiler for the Pi that will either go to 32-bit platforms or to 64-bit platforms. And so I picked up Helge Hess's version of what he had picked up from Johannes Weiss, and I made this thing, and there's the link to it, called Swift Cross Compilers. So here are some interesting links, by the way, and we'll go and visit these in just a minute as part of this. The original building Swift for the ARM platform was done by Umberto Raimondo starting in December of 2016. Neil Jones then picked that up and started building. Umberto had been building for the Raspbian OS, and Neil Jones picked it up and started building for Ubuntu, because Ubuntu was putting their operating system on the Raspberry Pi about that time. Helge picked up and did what he wanted to do, was to run Docker containers on Raspbian OS running, or a Debian based Linux running on the Raspberry Pi. and has subsequently gone on and done a Brew implementation where you can run a Docker container on your Mac and do cross compilation inside a Docker container on your Mac for Ubuntu. And then finally, there's my own Swift cross compilers project. So I had some objectives when I went to do this that other people didn't have. And I don't know that they are the same as anyone in this group is going to be interested in. But yeah, here they are anyway. That the first one was I wanted to be able to compile on the Mac and then deploy to my Raspberry Pis via Docker. So I want, without touching a Raspberry Pi at all, to create a Docker container, push that to Docker Hub, have a Raspberry Pi sitting out there in the field somewhere as part of my fleet, detect that a change has happened at Docker Hub, stop a running Docker container with my code in it, pull the latest Docker container from Docker Hub and restart it and keep going like nothing had happened. Essentially, I want the kind of deployment to my fleet of Raspberry Pis in the field that people who are running, web server farms get, where you push the Docker container and it goes to everywhere you need it to be. Now, I wanted my deployment to be distroless. I don't know how much you know about Docker containers, but most people think in terms of, I'm going to run an entire shell and operating system in a Docker container. But you don't have to do that. What you can do is set up your Docker container to run basically any OS distribution that you like, but only run it as a single program. So the entry point for the Docker container is not the shell. The entry point is not, an OS of some kind. The entry point for your Docker container is precisely your program. Now, when you do that, your Docker containers can get really small. That for really simple NIO servers, what I've found is that my Docker containers are about 3 meg. Now that's gigantic in terms of running on Arduino, but if you're running in terms of Linux distributions, that is just absolutely tiny. In fact, if I strip the debug symbols, I've had some of them get down as low as 900K. So what I wanted was for the Swift runtime. My 900K is my program, but that's not the size of the Swift runtime I've got. What I need is for the Swift runtime to be a one-time or at least a very rare deployment out to my machines in the field, right? So I want to be able to run multiple Docker containers with Swift programs as distroless Docker containers with Swift programs inside them that all share one Swift runtime to sit on top of. I want OTA updates to happen automatically, and I want this to work on ARMv6, ARMv7, ARM64, and AMD64 just because. So a little side note here, 32-bit support for ARMv6 has had problems since 5.1.1. It's been resurrected on ARMv7 for 5.6. As of 5.6, there have been a lot of people who've been getting 32-bit Swift to run again, submitting radars to Apple. But ARMv6 out there is still dead since 5.1.1, and I'd like to revive it. So my little things must support Swift NIO, Swift MQTT, and Swifty GPIO. That I want to be able to have a server running that can connect to MQTT, maintain the MQTT connection, and can respond to commands I send the thing over MQTT, right? So what does it take to build a cross compiler that will do this, where my entire workflow consists of doing things on Mac OS and pushing Docker containers, from Mac OS to Docker Hub. Now, the first thing you got to do is you got to get two identical versions of the compiler. You need the 5.7.3 or 5.8.0 for Mac OS and for whatever your target platform is. And you need, for every target platform you're going to go to. And by that, I mean 5.7.3 running on Ubuntu 20.0.4, 20.04.5, on ARM64 v8. You have to have a compiler for that matches the Swift version number for that platform and Mac OS. Then what you need to do is get the transitive closure of the dependencies for the Swift SDK. And this includes, basically all the C standard library that Clang would need, all the C++ standard library that you're going to need if you're going to use any C++ code, and any library that the Swift compiler depends on that platform. You have to find all of them, and they have to be completely linkable, that you can't have any undefined symbols. So this is what I mean by the transitive closure. So what we're going to see is that entails identifying a complete set of Debian packages, of Debian library packages, such that there are no references to any libraries outside of that set. And it turns out to be a fairly large thing. The third thing that you need to make this work is you need a linker for the target platform that runs on Mac OS. So Swift is going to produce .o files. Swift won't have any problem producing .o files on Mac OS. That's actually a relatively straightforward thing to do. But then you've got to link them in the format, in the ELF format, to run on whatever your final distribution is, whatever your final target is. Then what you've got to do is to take all of that and mix it together to form the SDK, the software development kit for the compiler, so that when you run the Swift compiler, it can find all the libraries it needs, it can, and link them all together. Then you've got to construct a tool chain for Mac OS to the target that uses that SDK and the native Mac OS Swift compiler to generate the final executable with all of its accompanying shlibs out there. Then you have to construct a destination file for the Swift compiler that has all of the flags that will make this work, right? And then finally, and this is the part that I really still need to do some work on, you need to construct the transitive closure of the runtime libs. So it turns out that Swift, if you're just running standard Swift on Mac OS, there is an enormous amount of stuff that can be accessible to you at runtime. So for example, there are things that ship in the standard distribution that are going to use what's the source library, the language support platform that you can pull in and run the compiler from your running program. All right, you're almost never going to need that. I mean, conceivably, you could need that in any program you write. You could just say, oh, I'm going to do SourceKit manipulation. SourceKit, that's what I was trying to think of. You could say, I'm going to pull in SourceKit because that's part of the standard distribution. And when you do that, you're pulling in a gigantic amount of runtime. So what needs to happen is we need to identify some executable that for my purposes represents having Swift NIO in it, represents having Swift MQTT in it, and represents having Swift Swifty GPIO and maybe one or two other things. And the runtime that we need to ship in a Docker container out to to the client machines needs to be the transitive closure of the symbols required for an executable that links in those three things and doesn't include SourceKit and doesn't include other things. If you get the full set, the full transitive closure of the runtime right now, it turns out to be about 700 meg, and that's just ludicrously large. But I haven't finished doing all the work to narrow that down. Okay, so what are the challenges of doing all of this stuff? How did, what's it take to go and build? Well, the first thing is somebody other than me has to construct the target compilers that, and Neil Jones, has been doing incredible work keeping that up for like 3 different flavors of Ubuntu, which are the things that I use. That I need to maintain separate configurations for every target and Swift version pair. So you'd like to be able to construct the compiler, for Swift 5.3, should you need that. That, we need to be able to generate these destination files, and the things that can go into Swift destination files, poorly documented doesn't even begin to describe it. You basically, are thumbing through code trying to figure out what changes they've made. That this has just not had any documentation effort put on it. Third thing is that the linker that we needed to run, the linker that would actually do the linking of the ELF files on Mac OS is the GNU, LD. And so ld.gold did not want to work on Mac OS, and so we've got a patched version of that has to be applied when we're building the cross compiler. We need to identify what that transitive closure of the target platform SDK libraries is and the runtime libraries. And then finally, we need to be able to construct a viable runtime container. And by that, I mean, I need to be able to construct Docker containers that contain the Swift runtime that can be shared between multiple Docker containers running on the same machine. So to-dos, I need to automate the testing of the runtime Docker containers on Mac OS M1. So the really cool thing about running for the Raspberry Pi platform, which is and the ARM64 platform that I have been targeting, is that I can actually cross-compile for on my Mac M1 for Ubuntu, Focal, and run that cross-compiled application inside a Docker container running on my Mac. I could actually go and do a fair amount of unit testing for the Raspberry Pi without actually running on the Raspberry Pi. Now, the things I can't unit test are accessing the GPIO pins, but I can unit test, like all kinds of stuff, including every bit of Swift NIO and every bit of Swift, MQTT. So I need way leaner runtimes. My runtimes need to get down to about 30 meg. And at the moment they're 250. That, I need to get a lot out of the runtime because I'm carrying around all of SourceKit and I'm carrying around, everything else that I don't need. I need to resurrect the ARMv6 compiler in order to run on the Pi Zero W. And my main interest right now is I'd really like to run on ARM Cortex, M0s. That, what I would love to do is have the cross compiler that for the ARM6 toolchain spit out code that if I don't include the standard library, and if I do the, sort of the kinds of things that you guys have to do in the Arduino community, I can now go and take Swift code with this compiler and run it on the Raspberry Pi Pico. So what I'm interested in doing is having the RP2040 as my target embedded compiler and replacing those ESP32s out there. That other people, we have partners who do the ESP32 based setup. And what I'd really like to do is be RP2040 based. So that's the kind of stuff I'm doing. I was going to go and quickly show some of the resources out there for doing this stuff. And then if anyone had any questions, I was going to kind of open the floor up and say, hey, how, or better yet, if anyone has got answers for how, if I had an ARMv6 compiler, how I could get that to be generating code for the RP2040, I'd love to hear it. So the first thing that is probably worth looking at if you're going to think about doing the cross-compiler technology is to start with Umberto Raimondo's GitHub link that he hasn't updated in the past couple of years, but it gives you a really good sort of state of the art as to things that can be done. So I know that on Raspbian that he does have ARMv6 running as of 5.4. Now, when I tried to do 5.6 last spring, essentially to build the Swift compiler for ARMv6 involves getting a Pi Zero and getting all the Swift compiler code on it, plus GCC and LLVM and some other things, applying a couple of patches because the Swift package manager doesn't distinguish between ARMv6 and ARMv7. Apparently, Apple never did an ARMv6 implementation, and so package manager, when it sees ARMHF in the triple for the compiler, says, "Oh, I'm going to generate ARMv7 code." So if you patch that, you can actually build an ARMv6 compiler on a Raspberry Pi Zero. Now, the last time I went to do that, it would get, and that process takes something on the order of 4 days to complete. The last time I went to do that, it was dying 3 days in, mainly because I think it ran out of memory. And what I need to do is go and get that resurrected and get it to the point where I can build a full ARMv6 toolchain. Then I can bring that back and I can run all of my code. I can run my scripts to do all of that assembly of the cross compiler. Another interesting link to go and look at is Neil Jones's link, where he does the ARM64 servers and keeps this up to date. So if you're wanting to build a cross compiler for something like Raspberry Pi or any ARM64 platform that is running any of the Debian derivatives, this is a great resource to go look at. This is basically where I download my target compiler technology. If you want to see the history of how the cross-compiler stuff happened, you can start with Helge Hesse's implementation, right, which he now points to mine. And he picked this up from Johannes Weiss at Apple to do. And Helge's approach to this was he wanted to run things in Docker. So you can look at his Doc Swift on ARM repository, and you can see how to get cross compilers for ARM running in Docker containers on the Mac. Helge then went and has added this ability to run these Docker containers, on the Mac to Homebrew. So, you can actually do the cross compilation. There are a number of cross compilation targets that he has kept up to date up through 5.6. And you can just get those accessible to you in Homebrew. So finally, you can go and look at my project, and the entire point of what I did was to try and make this easier, make the process of generating a cross compiler easier by simply specifying a configuration file. So if you go and you look, what my scripts are doing is taking all of this configuration information right here, mainly where to get the libraries, what the libraries are that are required. And you can see this is the full transitive closure of libraries necessary to produce a cross compiler, a Swift cross compiler on a Debian platform. Right? You just go pull them from the basic Debian locations. And in this case, I'm doing Ubuntu. And so I'm starting with an Ubuntu Focal ARM64 compiler from Neil Jones. I'm starting here with 5.8 direct from Apple. And then I'm specifying if my deployment platform is Ubuntu Focal, these are all the libraries that I need. Right? And this is kind of a fun thing that will go and build for you. If you've pulled my repo, that will actually go and build everything to where you can make an installer package. It turns out the installer packages have now gotten up to be about 6 gig in size, comparable to what Apple's installer packages for Xcode are. But you can go and so I can't post them anymore. I used to post them to the GitHub repo so that you could download them, but GitHub won't let you upload anything bigger than 2 gig as a build artifact. So nowadays you have to do it yourself. So what I'm looking to do is build this, deploy it in Docker running on Yocto project Linux as an underneath, as a substrate underneath, put Docker on top of that, and then start loading my distro-less Docker containers. So the ultimate idea here, just to give you a flavor, kind of circle back around, what we're going to be doing, the project that I'm working on right now is embedding RP2040s, battery-powered RP2040s in these big foam blocks. And we will surface NeoPixel light rings, for example, on the faces of the foam blocks, so that when you connect 2 of them together, and you've done it right, they will flash and indicate the connection, and that the RP2040s inside the blocks are connected to MQTT running on a Raspberry Pi nearby, and they will signal what they are connected to. And the big fun thing for that is that we have a version of Scratch. I don't know if any of you guys have ever played with Scratch, but we have a version of Scratch that kids can program. This is MIT's Scratch coding environment where kids learn to code in a drag and drop way. And our version of Scratch connects to MQTT. So, for example, if I want to do lights and sound, I'm going to set the volume on my sats to be level 4. I'll do all satellites. I'll come back to lights and sound, and I'll play a sound again on all my satellites. And my sounds that are available are things, we have 300 sounds available for kids to play with. And let's see, I want something like, what's a good one? Some of the Scratch sounds are really fun. So we can do, oh, we'll do the ding-a-ling thing. Let's do that. And what you should have heard just now was the satellite, and I've got a satellite to show people that what you just heard was this thing. There, let me get the right distance. What you just heard was this is the satellite with the ESP32 in it, and it's got the sound and the light and all that kind of stuff. So what I'm looking to do is talk to other people in the community about getting an RP2040 running Swift embedded in something like that satellite. So that was the discussion. Paul, I don't know if you're still out there, but
Yeah, I've been here listening the whole time.
okay. All right.
Yeah, that was great.
All right.
Cool. Well, I definitely enjoyed this. Do I have any answers? Not at all.
Okay. Well, what I'm looking for, what seems like it ought to be possible, and maybe people in the community can steer me towards this. What seems like it ought to be possible is if I resurrect the ARMv6 cross compiler, right? And I say generate this, here is some code, C libraries, C++ libraries, and and Swift and my Swift code. If I say run that through the ARMv6 cross compiler and don't link the standard library and only link statically the libraries that I have provided you, that seems to me like it ought to be something that I can run through the flashing process to put on an RP2040.
Yeah. I think there's a lot of, and this is not what I've been, doing as much with on this project. So I think we'll post this up and maybe we'll have kind of a async discussion because we have so many people in different time zones.
Yeah.
But I know with the place that I work right now is there's a lot of interest in some of like the WASM, Swift WASM stuff as well. And from what I understand, and I've yet to dive completely into that, but they also have problems with runtime sizing.
Yes.
And then keeping that lower.
Yeah. So that's Max Desayatov doing the tokamak WASM Swift WASM project.
Yeah.
And much of the work that's been going on with SPM lately has been targeted at building cross compilers. Max has been driving that. And not anybody really from the embedded community or the Raspberry Pi or the single board community.
Yeah.
And I think it suffers from our lack of involvement.
I would agree. I think there's a lot of aspects or pieces of this, and currently I think the WASM guys are like, there's probably the most interest there, and then it's also probably the most more mature. I think they've also have I think it's actually listed and shown on the Swift website, I think, as well, which maybe helps. I know there's talk of, at least a couple of years ago, there was talk of starting like a embedded or kind of a work group.
This was last year that
you're right, it was less.
Yeah, Ted Kremenek.
Yeah, it's a little over a year ago.
Yeah, that was where I first encountered Carl.
Okay, yeah.
Was I was on that call?
Yeah.
and Apple asked for, well, what can we help you guys with? And nobody else volunteered to speak. And I said, well, I've got problems. And
Yeah.
so
Yeah.
like the first 10 minutes of the call were me, talking about cross compilers.
Yeah. Yeah, Carl's been quite involved in a lot of that stuff. One thing that I've was mentioning and just kind of in our interest, and I don't know if like for our particular project is I know we want to support even just our compiler on other sorry on Windows and Linux, and then even sometimes just different distribution desktop. You need different. There's, it's like, oh well, this is using this version of Python, and that's using that version of this, and
Yeah.
to be able to like simplify, because again, like a big thing that I'm interested in personally is sometimes setting up these build environments is rather complicated, and I think this excludes a lot of people from it's creates such a high barrier to entry
Yep.
as well, and that's kind of what I was mentioning earlier, that I think this is. And yeah, anyway, I'm it's kind of fun to see your project and what you're working on, the deploying software to the hardware,
Yeah.
being able to compile and
Yeah.
then just send it out to that, which is
I have a
an interesting.
in OTA updates, and I was trying to figure out sort of where the Swift Arduino community was on doing. Yeah.
Yeah, that's not something that we've um, dug into. So I've got some projects and things in mind that I want to work on, like using some of our tools. It's just my stuff. And that's something that I need to look at it eventually is the over there updates. But I've not yet dug into the bootloaders on our stuff. I think a lot of the time as well, and I guess one question, and I guess I'm thinking is like I feel like a lot of companies currently they'll build, their stuff, and then you just have like an image. And I guess a lot with, and I guess you're really looking at full single board computers and not just a very small, like a microcontroller or
Yeah. The smallest
something like
I'm going
that.
to go down to is the Pi Pico. And in
Yeah,
fact,
the Pi
I'm
Pico.
looking at the Pi Pico W, which
Oh, okay. Is it a different chip?
it's
I'm not as familiar
it's
with
the
theirs
same
yet,
chip. It's the RP2040 chip, which is dual
but
core.
have they added
They
some
added
radio?
a Wi-Fi,
Oh, sweet.
actually,
Built into the
yeah, built in.
actual same silicon chip.
Yeah,
It
so
doesn't, it's
there we
yeah,
go.
there you go.
That
Okay.
So what I've got there is the Arduino Nano RP2040 on the bottom,
Yeah.
and this is the RPi Pico on the top. So the Arduino device has the Blocks Wi-Fi chip, and I've forgotten which Wi-Fi chip the Pico W has on it. But yeah, makes it a little bit bigger. They've got room for the antenna.
Oh, okay. So does the Pico, do they still use the same RP 2040
Yes,
40?
it's the
But then
exact
they have a separate
Wi-Fi.
package for the Wi-Fi. They have a
Yeah,
separate Wi-Fi module.
yeah, exactly.
Okay. But they're not including the Wi-Fi radio logic like on the same chip die as the 2040, like an ESP.
No, you link in. I mean, you specify when you're building. Like I've been playing around with VS Code on
Yeah.
this, and they have this tool that says, okay, pull all of, pull this library and this library and this library and drop it into the project, into the VS Code project. And so they've got the Wi-Fi library that talks to that Wi-Fi controller. Yeah, and I think it uses one of the UART ports to communicate.
Yeah. But basically, yeah, it's using a separate controller, a separate piece of hardware.
Yeah, exactly.
Hmm.
So,
Yeah, I know we had a little bit of a discussion as well. So I know ARM, the ARM Cortex
yeah,
Zero, and all those are things that are on our
yeah,
radar. I think Carl's been doing some work there,
yeah.
and it's definitely stuff that we want to be able to support.
Yeah.
Um,
So what I was thinking is sort of the first step in that kind of support is, so the Cortex is ARM v6 instruction set. And that's why I've been harping, or I was harping in the presentation on an ARM v6 compiler, right?
oh, okay. So the ARM Cortex they're all V6,
They're all
you
v6.
said?
Yeah, that's
Oh, okay.
yeah, I was going, oh crap, we should have been v7. Because because the v7 compilers are out there. There are tons of people who are doing these,
Uh-huh.
these compilers for the v7, but I need it for the v6. And the v6, it's hard to compile for, right? That
Huh.
you need the full to assemble the cross compiler, you need the full target compiler.
Yeah.
And the only way to get the full target compiler is to compile the whole Swift toolchain on a Raspberry Pi Zero.
Yep.
And that's a 4-day process when it succeeds.
Yeah. I know a lot of people, and I've poked at the stick at the like
Yeah.
playing with Swift on their Pi, and it's like you send your code over and then you sit there waiting for
Yeah.
ever for it to compile.
This is why I
And
cross compile.
yeah. And it like, yeah, I remember being like, why can't I compile this and send it over like I
Yeah.
would with the phone or
And you can.
whatever?
But
Yeah.
it's not, it is not for the faint of heart.
Yeah.
So
Yeah.
So the way I think, the way I see myself being able to contribute to this community is, hey, I want to do this RP 2040 thing. I'm going to go see if I can resurrect the ARM v6 Swift compiler so that we can have, running code for Swift 5.8 on ARM v6. Now,
Yeah.
that will compile on Ubuntu or Raspbian OS,
Uh-huh.
right? Which is going to have all kinds of schlibs to it. It's going to have the gigantic standard library. But I've been looking at people who are doing this compile with no standard library. And okay, that
I've
on.
sorry, I've got to run. I've got another
me too.
meeting now.
Okay.
Okay. Cool.
All
Yeah,
right.
we'll have to talk more on this. But yeah,